Welcome to the AI Research Roundup. I'm Alex, and today we're looking at a paper from the Hugging Face trending list, published on July 24th, 2025, so just a few days ago. This paper introduces a new framework for generating short movies that can maintain over 93% of its consistency, even when scaled to very long contexts. The paper is titled Captain Cinema Towards Short Movie Generation, and as we'll see, the results are really impressive. It introduces a two-stage process that first plans a movie's keyframes for narrative coherence, then synthesizes the video between them. So this first figure really sets the stage. It lays out the evolution of video generation on a long film strip. You have shot-level models like Sora, creating single clips, then scene-level models that can do about a minute. But Captain Cinema is aiming for the full movie level, generating long, multi-scene narratives. Key to their approach is an architecture called a multimodal diffusion transformer. This is a model that can handle both text and images using a diffusion process, which works by starting with random noise and gradually refining it into a coherent, consistent video. Building on that multimodal diffusion transformer, this next figure shows us exactly how they prepare the training data. They create what's called interleaved data. So they pull keyframes from across an entire movie. You can see different scenes here from Harry Potter, and pair each frame with a very detailed text caption. These captions describe the characters, actions, and even the atmosphere, using specific character name tags. This method of mixing images and text is critical. It's how the model learns to connect visual information with narrative context across a whole story. Okay, so this next diagram shows the core method, how Captain Cinema actually processes that interleaved data. It's a multi-step process within the multimodal diffusion transformer. First, it uses what's called hybrid attention masking. This just means the model pays attention to the image and text within one pair differently than it does when looking across multiple pairs, which helps build scene-to-scene consistency. But the really clever part is called GoldenMem. To remember a long history without running out of memory, it compresses older frames, keeping recent ones in high detail and shrinking older ones based on the golden ratio. This memory management allows for a very long but efficient visual memory. And this chart really visualizes the impact of that GoldenMem technique. On the x-axis, you have the number of image-text pairs the model is remembering, and on the y-axis, you have the total number of tokens. Now, tokens are just the basic units of information the model processes. Well, you can see the naive approach, shown in gray, just skyrockets. The memory cost becomes huge very quickly. But the GoldenMem approach, in red, stays almost flat. This proves how it keeps memory usage manageable, enabling that crucial long-term context without overwhelming the system. So we've seen how GoldenMem makes that long context memory efficient. But how does the whole system actually perform? Alright, this table gives us the numbers. It compares Captain Cinema, labeled ours, against other methods across several key areas. We see scores for visual quality, temporal dynamics, which is how realistic the motion is, and semantic alignment, meaning how well the video matches the text. And across the board, especially in the user study on the far right, their full model comes out on top. This really proves their whole approach works. Building on that strong performance, the authors then conduct a stress test to see just how far they can push their model. This table shows the results. They steadily increase the number of context pairs, which is the number of previous scenes the model has to remember, from 8 all the way up to 48. You can see the baseline method, LCT, just completely falls apart. As the context gets longer, its scores for scene consistency and narrative coherence plummet. But their model, especially with GoldenMem, is incredibly stable. Its scores remain high across the board. So, in conclusion, Captain Cinema really marks a significant step towards automated movie generation. By combining that top-down keyframe planning with an efficient memory system like GoldenMem, the authors have created a framework that can produce coherent, narrative-driven short films. That's it for this episode of the AI Research Roundup. I'm Alex. Thanks for listening.